recording. We're recording now. Hope you are too, Chloe. Hope everybody's having a good morning. Hey, we're doing math. It's got to be a good morning. Let's see. What did I want to? I think we just want to jump into what we're doing. Jump into Proctorio. So let me. I want to do DocCam. There we go. We'll get there eventually. Let's see. What we are talking about today is finishing up 1.6. I need to repair a little bit of 1.5. Rebecca pointed out to me yesterday that she was confused on something that I hadn't really covered. And I went into my math lab this morning and looked at just tons of you who left that problem off, number 5 on 1.5. So I know it wasn't just Rebecca. It never is just one person. So we will cover that. But before we do that, let's see, I want to cover take a baby step forward into your test. So right here, Proctorio practice deadline is February 5th. That's a week from this coming Friday. What you need to do to prepare for that, as we talked about the other day, is to go down here to the bottom slide, look at Ms. Campbell's 3-minute video on a room scan, get Proctorio installed on your computer, and then read over the things that are going to get you into trouble. This social services I did not have when we were talking the other day. I got it on Monday. I got it between the 8 o'clock class and the 2 o'clock class. This is an incredible PDF that the counseling services have put together that covers all kinds of things. Are you hungry? Are you in a domestic violence situation? Do you need, or do you know somebody who needs some suicide kind of counseling kind of thing? Just tons of local Tarrant County resources. So please, if you think anything at all, any social service in the county is covered in there. Okay, so back to Proctorio. When you have completed these steps, when you have loaded Proctorio onto your computer and you have looked at Ms. Campbell's room scan and read over the kinds of things that are going to get you into trouble, then you're ready to go take the practice test. So click on the Proctorio Test Proctor, and it should come up on this screen. Your exams are here at the bottom. These 3 are the same things that are at the bottom of my library slide. Here is Ms. Campbell's room scan. There's her name right there. And this is how to get Proctorio on. It's the same ones, so there's nothing new here. Your exams are here. Click on that. And then you've got this practice Proctorio remotely proctored. Here are the instructions. This first one, the first line will not, once you open this up, this first line will not be on there, but you need to note this. It will be on subsequent tests. This line will be there. I just can't figure out how to retroactively put it onto your screen when you get into your test. But if Proctorio cuts off, if your video connection cuts off, you must re-enter as quickly as you can, rescan your room and your desk, etc. Do the full beginning thing again. Remember, your job is to prove to me that you are not cheating on this test. My job is to make sure that everybody else isn't cheating so that you get a fair score. Okay, your room scan must include, number 1, show the entire room all the way around your room, 360 degrees as Ms. Campbell does. Number 2, show me under your work area as Ms. Campbell does. Number 3, show me your work surface as Ms. Campbell does. Number 4, this is the biggest problem I have with students because you're not understanding it from my point of view. Number 4, show me both sides of your scratch paper as they sit on your work surface. In a minute, when I transition back to my doc camera, I'll show you what I'm talking about there, the difference between what you think is adequate and what I think is adequate. And I'll make you do your practice again if you do it wrong, because I want to be sure when the points count, you understand what's expected of you. I don't want to take 20 points off your test first time you do it because you didn't understand what you were supposed to do. Number 5, show me your calculator and its carrier, if you still have the carrier, as Ms. Campbell does in her video. And then on this test only, on this practice test only, on the scratch paper, you need to copy every problem. That's only 3 problems, every one of them. Show every step you need to show as if you were going to tutor it or teach it, and then box your answer. I want a good solid scratch paper from you for these 3 problems. When we take a regular test, I'm not that picky. I'm not going to, if you need to show the step, you show the step. If you can do it in your head, I know that many of you can do lots of this in your head. The bottom line, sort of my rule of thumb, is if I can't do it in my head, you probably can't do it in your head. But on this test alone with the 3 problems, I want you to follow this direction. Copy every problem, show every step, box your answer. And then the last thing you need to do, get your scratch paper to me. That means you take a picture of it. That means you turn it into a PDF and upload it to Adobe and send it to me. Whatever your method is. One thing we had problems with last semester was loading up a bunch of papers. So if you need to send them one at a time, and on this test, on this practice test, you'll only be sending me 1 scratch paper. But in the future, you'll be sending me, some of you will be sending me 6 to 10 sheets of paper. You might want to send them one at a time. I need them. I don't need them if you try to send them all at one time and it doesn't go through, and then 2 hours later, I say to you, where's your scratch? Because it didn't come through. And you're like, well, okay, let me send them one at a time. No, I need them 5 minutes, within 5 minutes of when you submit your test. That's a crucial thing. Yes, you're sending them to email, Felicia. So just send them to cynthia.sarles@tccd.edu, my email address. And you'll do that for every one of these tests. And this will get so boring and so routine, but it won't be boring and routine the first time you do it. It'll be new and fresh and maybe a little bit anxiety provoking. And I'm trying to make it as little anxiety provoking as possible by giving you this practice test. When you do this practice test, I will email you back and say, you're good to go. Or, no, I didn't get a 360 room scan. You didn't show me your scratch paper adequately before you took your test, and I didn't get your scratch within 5 minutes. So why don't you redo it? You can go redo it. If you would like to, you can redo it 10 times if you want to on this practice. But I will let you know if you're off the hook. And I'm not going to let you off the hook until I'm sure that you understand the steps so that you won't lose 20 points or 50 points on a test that counts. This test does not count. Can we take the pictures on a phone and send them through the phone attachment so we don't have to make it? Absolutely, Kaylina. Whatever works for you works for me. And this is a way for us to see how you can get them to me quickly and efficiently. Yeah, you've got some apps that you can take pictures with on your phone and send them. I mean, I've had probably, 5 or 6 or 7 completely different ways of students sending me their scratch paper. It's whatever's convenient for you. I'm not picky about how you do it. I'm picky about how long it takes you. Okay, so you are welcome now to go anytime this week or next week. Your deadline is next Friday. The only people who can't take the practice test are those who have not cleared with me their chat. And that is 1 student for a chat and then 2 to get the proper equipment on their computers. So 36 of you are good to go here on the practice proctorio. As soon as you have done, just do it. You've got a week and a half to do it. You will not be allowed to take your regular test, your first test on February 12th, 10th, 11th, or 12th. You will not be able to take that test until you have cleared the practice with me. That is just me being your mommy and taking care of you so that you don't lose points on the first test. Okay, I think that we are good there. Let me go back to the DocCam. Okay, I told you that I would show you what I get from students. What I get from students, let's say that, let me see if I can do this the right way. I get students saying to me, okay, here's my scratch paper and here's my scratch paper. That's not good because they could be saying, here's a scratch paper and, whoops, sorry, that's not what I meant to do. They could be saying, here's a scratch paper and here's a scratch paper, and those are my two sheets. When in actuality, they have a complete set of notes right here that they're not showing me. So I don't want papers flying around in the air. I don't want you flapping them around in the air. This is the way Miss Campbell does it, and this is the way I expect you to do it, and you won't get cleared until I see you doing it this way. Remember on Proctorio, it says, as they sit on your work surface. So I want this, and I want it to be able to see it completely. So something like that, and that, this, and this. So I want to see both sides of your paper as they sit here, so I can see all of the papers you've got, and I can see both sides of all of the papers that you've got, not flapping them in the breeze. That's not good enough. It needs to be on your work surface so I can see that all of the papers that sit there are the papers that you have shown me both sides of. Your work surface needs to be clear. I know that some of you are working, when we did the chat, you're telling me that you've got desks with a lot of crap on them. Clear the crap off for the test. You're just going to have to do that. Follow what she talks about in her video. Okay, I'm tired of that. Let's move forward. Let's do some math. First thing I want to do is clear up number 5 from 1.5. They asked you for an extra step that I was not, I didn't notice that they were asking you for. This is the completing the square problem. Completing the square. And let's say we had x squared minus, well, the one we used was 25x. And I told you that all you needed to worry about was what went in here. And you put in, remember you're doing b over 2 and then squaring it. So it would have been 25 over 2, and then squaring it gives you 625 over 4. So you would have put 625 over 4. That's as far as I took you. In my math lab on number 5, they want you to take the next step, which is to get it ready for square root property. That would involve an x there, and then this minus sign, that sign there goes here. And then what you're going to put here is b over 2. 25 over 2, and then it'll have a squared there for you. So that's what they're looking for on their third, I think it was their third thing they asked you to do. Maybe just the second thing they asked you to do, but the last thing. So let's do another one of those. Let's say you had x squared minus 7x. You would take this b, 7 over 2, and square it. You get 49 over 4. So that's what they want here. But then they ask you to show this squared piece. So it's going to be x, then a minus sign, and then b over 2, 7 over 2. If we were doing those, I would present that in a different way, but this is as far as we're going right now, and I just can't recall if we ever dive deeper into completing the square. It won't be on your test, it won't be on the final. So you don't have to seriously worry about it as a, I mean, there's such a difference between being able to mimic it on a homework assignment and being able to complete it on a test. You just need to be able to mimic this. No one really uses completing the square there's so many better ways. There's quadratic equation and there's just factoring. Okay, so I think that's covered that topic. Let's move forward. We were in the middle of 1.6. And on 1.6, we've looked at getting your toes wet, getting your feet wet a little bit into different methods. We're going to look at squaring both sides. We're going to look at what to do with a radical exponent. We're going to look at those quadratic inform ones, those quadratic wannabes. First, though, as we start this in 1.6, doing the work, they're going to present a couple of ones you're used to. 9x to the fourth minus 36x squared equals 0. This is a quadratic one that's just a straightforward. The next two problems, this one and the next one, will be just straightforward problems that are review. Okay, first we're always looking for a GCF, so we're looking for the greatest common factor of 9 and 36, and that's a 9. And then how many x's can we take out of both of these? That'll be x squared. They both have an x squared they can give up. So let's GCF that out. Let's factor that out. If we take the 9 out, there he sits. We took 2 of these x's out, so we've got 2 of them left, then a minus sign, and then 36 divided by 9 is 4. X squared sitting here at the door. That's division work. If you're not comfortable with it, redistribute. 9x squared times x squared, cool. That's 9x to the fourth. 9x squared times a negative 4, good. That's negative 36x squared. So we're good so far. Now, this is 9x squared, and we can't factor him any further, so he's good. The GCF will just sit there. But in here, we can still factor this. So let's keep that 9x squared. This is the difference of two perfect squares. Anytime you have an x squared remaining, you kind of got to look at it and ask yourself, can I do something with that? Here we can't. When you've just got one term, there's no factoring that can be done further. But here we have two terms, and this will factor into the difference of two squares, x and x. You've got a sign there that's a negative. That tells us that the signs will be different. And then the square root of 4 is 2 and 2. Those are conjugate pairs, x plus 2, x minus 2. It's the same dang thing, except for one's got a plus and one's got a minus. If you FOIL this out, the outside is a negative 2x, the inside is a positive 2x, and those drop out. That's why we don't have an x term in here. We'll do this difference of two squares a kabillion times in this class, so get comfy. Okay, so we got it. We were given a 0. We factored this completely, and now let's use the property that allows you to separate out each piece and set each equal to 0. We're trying to solve for x here. Let's divide by 9. X squared equals 0. 0 divided by 9 is 0. Take the square root of both sides. It's just an overlap, a review of something else that we've done. Squaring and unsquaring cancel each other out, so we get an x. The square root of 0 is 0. You put the radical on, so you've got to consider both the positive and the negative version, but there are no positive and negative versions of 0, so we're just left with one answer here. It is a plus and a minus, but you're not expected to put that on there, of course. And then here, move this positive 2 over, it turns into negative 2. Move that negative 2 over, it turns into positive 2. So we get one answer, faking as two answers, a third answer, and a fourth answer. We got 4 answers, which is what we were expecting because we have a 4 for our highest exponent. But remember this one, there is a positive and negative version, but not when we have a 0. Because there's no such thing as a positive 0 and a negative 0. Okay, let's look at our second problem here where we're actually doing stuff instead of just getting our feet wet as we were on Monday. Let's look at x to the third plus 3x squared equals 49x plus 147. Okay, let's see. Let's look for like terms because we've got 4 terms sitting here. There's likely that somebody will be alike. But no, this is the third exponent of 3, exponent of 2, exponent of 1, And this guy really does have an exponent of 0. 147 has an exponent of 0, x to the 0. Anybody to the 0 power, this may be a detail you've forgotten or maybe we're never told, but anything to the 0 power equals a 1. So 5 to the 0 power equals 1. Doesn't seem like it should, but it's one of those details that you will need to find a spare brain cell for. Put that in that brain cell. Anything raised to the 0 power is a 1. So this piece is a 1. And that's just free information at this point, but we will use it later. So we do not have like terms here. 1, 2, 3, 4 terms. That means we're going to have to factor by grouping. So you got to get a 0, move everybody over. So we get x to the 3rd minus 49x minus 147. Now we're ready to do us some factor by grouping. So we're looking at these two terms and asking ourselves, what do they have in common? They have an x squared in common. We can drag an x squared out of each of them. That leaves us with x plus 3. And again, distribute if you're not comfortable doing the division to make sure you've done it correctly. Then you've got a minus sign in the middle. That needs to be brought down. And then we're looking for what 49 and 147 have in common. So let's see. Let's think big. Let's try 49. See if 49 will go into 147. So 147 divided by 49, and it does. It goes in 3 times. That's good. It's kind of going to have to, because remember, these have to match this set of parentheses with this set of parentheses. So 49 is the GCF there. And if we pull a 49 out of there, we've got an x. If we pull a negative, the negative, we've already pulled the negative out. And that's troublesome for a lot of you, to divide by a negative on this negative. If you're uncomfortable with that, if you're not sure what sign to put in here, remember that this set of parentheses is required to match with that set of parentheses. So just steal this, x plus 3 there, slap it over there, and then just make sure it works. Negative 49 times x gives you a negative 49x, good. And then negative 49 times a positive 3 gives you a negative 147. So we're solid here. Okay, now if you recall, in these factor by groupings, we're looking for what this piece has in common with this piece. They both have an x plus 3. So let's pull the x plus 3 out and gather up the leftovers. X squared minus 49 is left over. This is fully factored. This, as promised, I told you we'd have some more difference of 2 squares. We still have to do some factoring there. So keep the x plus 3. Difference of 2 squares, this will be x plus 7, x minus 7. And now let's use the property that allows you to set each piece equal to 0. So move that over, we get x equals a positive 7. Move that over, we get x equals a negative 7. And move that over, we get x equals negative 3. And sure enough, 1, 2, 3 answers. We got a 3 as our exponent, as expected, 3 answers. Okay, those are somewhat review, I hope, for you, although there may be some things in there that you're like, didn't know that. Let's move on to now exploring in 1.6 the things that we started out with on Monday, looking at just getting your feet wet. Remember, we looked at a couple problems with radicals in them, so let's go revisit that. 40 minus 3x under the radical equals x. Let's start with that. We looked at one and how to do it, but we didn't get very far in that. My math lab just wanted you to practice squaring this side and squaring that side. So when you approach this, you're like, okay, what am I supposed to do here? Well, you know you got to get the x's together. We need an x equals as our answer. We got x's on both sides, so we need to get them together. but this guy is under the carport. We got to get rid of the carport. We got to get a clean x out of this. Not clean x, that's funny though, but a clean variable. So in order to get rid of this radical, let's square it. Because you know already, squaring and unsquaring cancel each other out. So we've got 40 minus 3x on that side. We did that Monday. We just did that setup on Monday, that's all. We'll go further today. If you square one side, you have to square both sides. So we get an x squared there, and your brain should be going up, quadratic equation. I'm going to need to factor this. Quadratic equation or quadratic formula or regular old factoring requires that you get a 0 on one side. Here's our big guy. We know it because he's got the largest exponent. We want him to be positive. So I'm going to move everybody over to his side. So I'm going to get 0 equals x squared, move this negative 3x over and he turns into positive 3x. Move the positive 40 over and he turns into negative 40. And now, again, like I did the other day, if you don't like this on this side, get rid of him, move him over here. There's not going to be any difference. I'm going to leave him there just to play, just so you can see that it'll work out okay. Okay, so we need to factor this thing. Let's assume that it will factor into 2 sets of parentheses. That's the easiest way and quickest way for us to get this done. We need 2 signs that are different because we've got a minus back there. So I'm going to use a plus and a minus. And I know that of the problems, the factoring problems that you struggle with the most, this is the kind that you struggle with the most with a minus back there. So this is good practice, especially in class, so that I can help you learn it. So if you've got questions, ask. So what we need here in the 2 number places are 2 numbers that multiply to give us 40, whose difference is 3. They'll be 3 apart from each other. We need them to go in these spots. So, good, 5 and 8. If you can think of it, great. If you can't, start out with 1 and 40. Those multiply to give you 40, but their difference is 39. So then ask yourself, well, let's move up. Will 2 go into 40? Yeah, it will. That difference is 18. 40? No. Will 4 go into 40? Yeah, 4 will. 4 times 10, that difference is 6. We're getting there. Will 5 go into 40? Yeah, 5 times 8, and there we are. So if you were like Chloe and you already knew it was 5 and 8, then you don't have to go through this routine. This is just instead of praying to the math gods that it will come to you. Okay, so we've got 5 and 8. 8 is the large number. Always grab the big number. You want him to win. So you are going to pair him always with the first sign in the problem. So we're going to put the 8 with the positive sign. 8 goes there, 5 goes there. Let me show you why. That's okay. This is the place to make mistakes, Kaylina. No worries at all. What is important is that you understand why. That's what I want. So let's look at why this works. X squared is not a problem. We put x's down there. We're going to get x squared. That's a guarantee. It's also guaranteed that we're going to get 40 because we're only looking at numbers that multiply to give you 40. It's 3x, the middle child, that's the problem, because middle children are always problems. I don't know about you, but that's my experience. So let's make sure we can get 3x out of this, and a positive 3x. Outside right now is a negative 5x. Inside is a positive 8x. That's the way we're getting that positive 3 that we need, is by putting our big guy on the positive so that he wins, his sign wins, and we end up with a +3. So the way to determine it is always on these ones where you've got different signs and a 1 in front. Yeah, absolutely. Yeah, absolutely, Chloe. Everybody's got different ways of doing it if you're doing it successfully. And whatever way works for you. And that's what we're doing. A positive 8 and a negative 5 will give you a positive 3. That's why you want this one to be a positive and that one to be a negative, so you can get a positive 3 out of it. If you had put the negative here and the positive there,
-8 and a +5 gives you a -3. We don't want a -3. So we're putting the big guy with the plus sign. I kind of like your method better, Chloe. I think I'll probably start using that rather than linking that, because I just have students struggle with it. But yeah, put signs on there and see what happens. Thank you. I always get good ideas from students. Okay, back to this problem. Let's separate this out. 0 equals x minus 5. Move the 5 over, so you get x equals 5. Move the 8 over, so you get x equals -8. Those are the two answers. However, this is a little bit of a problem, because what happens in here sometimes does not work. When you're given a radical problem, weird stuff can happen. So let's take this original problem, square root of 40 minus 3x equals x. We have to do a check. Sometimes they won't work, and we'll see that. So let's try out our problems. Let's check -8. So I'm going to put a -8 in here and in here. I'm going to put my two answers. I'm first checking the -8. So the square root of 40 minus 3 times -8 equals -8. I know that's not going to work, because whatever I get for the radical, I didn't put it on. So I'm going to take a positive root out of this. It's never going to equal a negative number. We can keep going, and we will. This is 40 plus 24. That gives you square root of 64. And you know the square root of 64 is a +8. When we did not put the radical on, we only accept the positive root. So this guy didn't work. -8 didn't work. So that's not our answer. Let's check and see if 5 works. Check 5. 40 minus 3 times 5 equals 5. Putting 5 for each x spot and just seeing if it works. 40 minus 15 equals 5. Square root of 25 equals 5. Yeah, that one works. So here's our answer. Now, what's the problem with that? You're taking a multiple choice test once you get done with the homework. The homework, you'll have to put in the answer. But on a test, you're going to have answers like this. And if you do the problem, you're like, cool. Oops, you just missed 4 points on the test, even though you did everything correctly except check the answer. So here is my suggestion to you. When you've got 2 answers and you go look at the answers from which you get to choose, and you see that there's your answer, but ooh, they've taken away one, maybe they don't work. That's a big fat hint to you that this is a problem that needs checking. So if you are afraid that you're not going to remember this, look at the other answers. Why are they taking away an answer? Why are they doing that? Ah, you say to yourself, I need to check my answer on these that have square roots. So this is a huge pitfall. You've got to remember to check it. We will do it here. You will practice it on my math lab. You will practice it on the review. You will practice it on the test review that you will take as a test, as a pretend test on my math lab. And then you will have it also on your test. So you've got lots of repetition there to recognize that radicals need to be checked. Okay, let's move to our second radical answer or question. Problem. Square root of x minus 3 equals x minus 5. Okay, it's got a radical, so I know I'm going to have to square this side in order to free up what's underneath that carport. So there we go, that freed that up. If I've squared one side, I need to square both sides. This is a FOIL problem. This is not x squared plus 25 or something like that. This is x minus 5 times x minus 5. So we get x squared minus 10x plus 25 when you FOIL it. Okay, you see that x squared? Your brain says, ha, I'm going to have to factor this. So you need a 0. Let's move these guys over here, over to the right-hand side, because our big guy is positive where he sits. Don't bring him over here. So let's do a minus x. That'll get rid of him. I'm going to column up the minus x here. So we got like terms. add 3 over there, so add 3 there. So we get 0 minus 11x plus 28, and this is a good factoring problem. Let's see what we can do. X's will always give us x squared. You're never going to have to worry about, am I doing that part right? We got a plus sign back here. That tells us these signs in our answer need to match. They either both need to be pluses or they both need to be minuses. Well, we need to get some negative in this problem, so let's use both negatives. Good. Both negatives. And now what two numbers multiply to give you 28? That when you add them together, and we're going to be adding because the signs are the same. Good. Because the signs are the same, so we're going to be adding them together. Gives us 11 and 7 and 4. So doesn't matter where you put the 7, doesn't matter where you put the 4, because they're both on the same template of x minus. There's no difference between the two sets of parentheses. Okay, so 0 equals x minus 7, 0 equals x minus 4. Move the number over, we get a 4. Yeah. And we get a 7. Those might both work. Neither one might work. Let's check them out. So if we do checks, go back up to the original problem. Let's check 7 first. 7 minus 3 equals 7 minus 5. I'm putting in a 7 for the x's. Plugging it in, see if it works. Square root of 4 equals negative 2. Oops, sorry. Square root of 4 equals 2. 7 minus 5 is 2. Square root of 4 equals 2. Yeah, square root of 4 is 2. So that's a good answer. 7 is a good answer. Let's try 4. In the original equation, 4 minus 3 there, 4 minus 5 there. The square root of 1 equals a negative 1. No. If we had put the radical on, yeah, that'd be allowable. And in European countries, and I think probably everywhere in the world, this would be correct. But in America, when we have the radical there, we only take the positive root. So 4 didn't work. The only answer you've got that works is 7. So you're going to have to check those that start with a radical, that have a radical on them when you get the problem. Okay, let's do one more square problem, one more that's got the radical to begin with. And this is going to require a certain amount of brain work. This is, you can get lost in this problem. Let's look at the square root of x plus 18 minus the square root of x minus 9 equals 3. Okay, we have two radicals here. So if we square them, we're going to end up with like a foiling kind of thing. We're going to end up with a mess. So that's what we're going to have to do, though. First thing you want to do is isolate one of them. You want to get one of them by itself. So let's move this guy over here. Let's say plus the square root of x minus 9 plus the square, oh, sorry, can't change the sign on the inside. That's boo-boo. The square root of x minus 9, the square root of x minus 9, add to both sides. So we get the square root of x plus 18 equals, and order here doesn't particularly matter. I'm just going to put the 3 first. We're going to mess with it a whole lot. So unless you're really comfortable with what you're doing, do it my way right now because I don't want to lose you. Okay, now we're ready. Let's square this side so we can free up x plus 18. Whatever we do to one side, we're going to have to do to both sides. Oh, that's a mess. Let me show you what this is. This is now 3 plus the square root of x minus 9 times 3 plus the square root of x minus 9. Foiling, we're going to foil this. This says write this binomial twice. So that's what we've done. First, 3 times 3, that gives us a 9. My guess is I have not lost anybody yet. That's handleable for all of us. Now let's do the outside. That's 3 times the square root of x minus 9. That'll give us 3 times the square root of x minus 9. Now let's do the inside. That is also 3 times the square root of x minus 9. And now let's do the last. A positive times a positive is a positive. A radical times its very same self. Let's look at what that's like. If we had the square root of 5 times the square root of 5, you know that gives you the square root of 25, and the square root of 25 is just 5. Let's look at the square root of 6 times the square root of 6. You know that gives you the square root of 36, and you know the square root of 36 is just 6. We have the square root of x times the square root of x. That gives you the square root of x squared. Squaring and unsquaring cancel each other out, so we just get x. So when you take a radical times his very same self, you free him up. So the square root of x minus 9 times his very same self frees him up. Good, just x minus 9. Okay, let's make some sense of all this crap. Let's see, let's combine some like terms over on this side. Let's leave this x plus 18 here. Let's see, I've got a 9 and a minus 9. Those are the only two constants. 9 and minus 9, so those cancel out. I have an x, and then these two are like terms. I've got 3 of those things, radical x minus 9, plus 3 of the same thing. So if I have 3 of that blob and 3 of that blob, I've got 6 of that blob. Okay, here's where we're going with this. You know that what we did earlier was we got this guy by itself, we squared both sides. Now we're going to do the same thing. We're going to get this guy by itself and square both sides. So this is like the shampoo bottle. We've done some lathering, we've done some rinsing, and we're going to repeat. We're going to get this square root of x minus 9 by himself. So let's move the x over here. Minus x, minus x. Ooh, that's sweet. We've got that. Still trying to get to x. Let's divide by 6. Oh, that's nice. And now we've isolated this radical. Let's square this side to get him by himself. And if you square one side, you have to square both sides. And now let's solve for x. Add 9 to both sides, so we get x equals 18. Okay, we only got one answer. We never dealt with squares. Let's check our answer. You got to check these. So let's put it back in the original equation. 18 plus 18 minus 18 minus 9 equals 3. Okay, that's 36. That's 9. So it's 6 minus 3 equals 3. It checks out, and we've got an answer. Okay, that's just fun. And these can get so much wilder, and I don't believe we get wilder with them. We don't get crazy here. I mean, there's some nice stuff that happened here. The 9's canceled, the x's canceled. So you had and this was a whole number. You had some really sweet things that don't have to happen. But did. This is the level of difficulty you will have on my math lab, and you will not have one of the double variety on your test. You can expect ones like this on your test with one radical in the problem, where you, like this, that was the check. But like this, where you've got a radical that squares out, and radicals both that square out, that's fair game. But one where you've got to move it over and you've got to FOIL a radical piece and a regular piece. We won't have that on the test. It is on the homework. It is good learning. Those of you that are going further, oh my gosh, of course you need to master that. And if you're getting stuck on it and can't use this as a model, bring it to class, email me, any of that. Let's get it solved. Yeah, so Anthony, you feel that you can probably model, well, we'll see. We'll see if you can model your way through a problem on my math lab. If not, you know how to contact me. You see other friends of me.
But yeah,
Say it again, I'm sorry.
it will probably take a while, but I'll get it.
Well, just use it as a model. Just use.
Now these other problems, you got to figure that out. You've got to be able to do those. But when you're doing this one, just use your notes on that and follow it step by step. And nice things will happen, like the 9s will cancel, the X's will cancel. Okay, that's good enough for squares. The next thing we looked at was rational exponents. Last time we met, Monday. Let's play around with them a little bit. Let's look at x to the 5/3 equals 32. Okay, we need to get x by itself. So like we did on Monday, you need to take this piece and you need to raise 5/3 to its reciprocal, to the 3/5, because 5/3 times 3/5 will cancel. 5/3 times 3/5, 5 times 3 is 15, 3 times 5 is 15, that gives you a 1. That's what we want. We want x to have an exponent of 1. That's what x is, with an exponent of 1. So we've taken care of the left-hand side. Whatever you do to the left, you've got to do to the right. So let's raise this guy to the 3/5. And now let's play. Let's learn something. Anytime you have a rational exponent, that's the same thing as putting 32 under the radical, making the denominator be the index. Put the denominator, let's see, the denominator is the index. So take the denominator and stick it up here. And then the numerator, we're going to raise the whole thing to the 3rd power. So get this structure in place. We're going to do this 3 times. You will get the hang of this after 3 times. We're going to, anytime we've got a rational exponent on a constant, we're going to put the constant under the radical. Then the denominator is the index. So the 5 will be the index here. And then we will raise the entire thing to the numerator, to that power. Another way of writing this could be like this, 32 to the 3rd, but you do not want to say 32 times 32 times 32. That's a big old number. And then take the 5th root of it. You don't want to be doing that. So I'm always going to write it like this. I might remind you a few times that these are identical things, but we want to smush this number down first. Let's get the 5th root of 32. Let's find out what number times himself times himself times himself 5 times will give us 32. You don't have to know that. You'll get better at these as we go, but let me show you how to find it in your calculator. I've already shown this to you once, so there's no way I expect you to be an expert in this. And as I recall, I muffed it up first because it's so backwards to me. We need the 5th root, so put a 5 in there. We're looking for the 5th root. Now we want to use this key that's above the caret key. We want to use that little one there that has the x root of the x as being the index. So hit second humpy. Second humpy gives that to you. It brings up what's in the gutter there. It's saying the 5th root of 32 equals 2. So let me go through that again quickly. You're going to put the root in there, the index in there first, 5th root. And then you want to pull up the function that's above the humpy key, above the caret key. So it's second humpy there. And then put the 32 in there. So that's saying the 5th root of 32, and that's a 2. So what we've got here is x equals 2 to the 3rd power. Don't forget we've got this numerator. And then you can do 2 humpy 3 or 2, 4, 8. And 8 is the answer. I don't think that's ever going to cause any grief, so you don't have to check that. I've got it in my notes that you do, but I'm pretty sure you don't, so we'll see. We'll see how we go. Okay, let's look at the next one of these. Let's look at x minus 7 in parenthesis raised to the 3/2 power equals 64. Wait, where'd you get 8? That's 2 to the 3rd power. So it is, if you don't know it or come across one that you don't know, 2 humpy 3, 2 to the 3rd power equals 8. Or you can go 2 times 2 times 2. That's 2 written 3 times. That's what that says, and multiplied. So 2 times 2 is 4. 4 times 2 is 8. You good, Chloe? Ah, yes. Yes. Your finger has to be smart. It does. Okay, x minus 7 to the 3/2 power, that's a rational exponent. It's a ratio that's acting as an exponent. So what we're going to do is we are going to raise this to its reciprocal, raised to the 2/3 power. That will cancel out. The 3 on top will cancel with the 3 on bottom. The 2 on top will cancel. And they're not canceling. Ms. Campbell is very careful about this, although you won't see that in her video. But she always comes to mind when I say cancel. We're not canceling. They become ones. 3 divides into 3 one time. 2 divides into 2 one time. So we're getting x minus 7 to the 1st power, if you want to write it like that, but that 1st power just goes away. So we're freeing this x minus 7 up. So x minus 7. Okay, whatever we do to one side, we have to do to both sides. Let me raise 64 also to the 2/3 power. Anytime you've got a constant raised to an exponent, it's more familiar to you to put it in the radical and transfer it from rational exponent to radical form. These will be the same identical things. This just makes a little more sense to our brains because we're used to it more. Remember that the denominator is the index. So the denominator is a 3. Let's make that the index. So we're going to be talking about a cube root. And then we're going to raise the thing to the 2nd power. You might know what the cube root of 64 is. That's what times what times what equals 64 with all those numbers matching. But you don't have to know that. You got a handy dandy calculator that you paid $8 or $10 for. So let's cube root it. So put the 3 in there. And then let's pull up the function that's above the humpy key. So 2nd humpy gives you that. 4 equals 4. So it's 4 times 4 times 4 will give you 64. 4 times 4 is 16. 16 times 4. So we've got x minus 7 equals 4. Don't forget, we've still got to square it. We've got to raise it to the 2nd power. So x minus 7 equals 16. Keep getting x by itself. Move the 7 over there. It'll turn into plus 7. And x equals 23 there. Doesn't look much like a 3. X equals 23. Okay, we got one more of those. Anybody not ready for that? Amanda, yes ma'am.
I was wondering if it just makes me too lazy if I just put the 64 to the power of 2/3 in the calculator and just get the answer. Is that
64.
okay?
Let me show you what Amanda's talking about. Oh, it makes it so much easier. We got 64 raised to the 2/3 power, 64 humpy, 2, ABC 3 equals, look at that, we get 16 out of that. She's done 2 steps in 1 step.
Wait, what's that 2nd step you did? I just put it in parentheses. What did you?
Oh, you multiplied it times 2/3.
Yeah, I just put in parentheses, put 2 divided by 3, and I still got 16, but I don't know what you did there.
That's a coincidence. That's just a coincidence, Amanda. Let's check this other one right here. Where were we? 32. You're saying 32 times 3/5?
No, Like put the little caret key, 32 caret key, then the parentheses, 3/5.
Okay, yeah.
And then,
Yeah, I
yeah, the
think and then how did you do 3/5?
3 divided by 5.
Oh,
And then,
okay, okay.
and it still gave me
Yeah.
that same answer.
Yes. Yes. I misunderstood what you're using the caret key, so we're good. Yes. You know, in 0362, I don't let students do that. I show them that it works. And in fact, that's what we're going to stick with. That is a way to check your work. But when you turn in your work, I need to see this. I need to see that you understand that. So thank you, Amanda, for helping everybody to have a way to check it. So you are allowed to do that to check it. Like if you wanted to do 64 raised to the, and then 2/3, Amanda did 2 divided by 3 and got, whoops, that's, oh, in parentheses because, yeah, because of order of operations. Let me show you with the fraction key. So 64 raised to the 2 ABC. ABC is a fraction key. See, that's 2/3 right there. It knows it's 2/3. So this is 64 raised to the 2/3, and there you get 16. You get, when we, here we are. I did the 3rd root and got a 4 and then squared it and got 16. So we're getting to that point. That's a great way to check your work. But I need to see on your scratch paper that you understand what you're doing. I want to see that you know that 2/3 means the same thing as a 3rd root squared, and that you can get 4 squared and get a 16 out of it. And I'll check it. I'm the super duper checker of scratch paper. So use it as a way to check your work, but I need for you to understand that. Yes, absolutely, Adrian. So come in at about 3 o'clock when you come back. We'll be at the same place, maybe a couple minutes till, so you don't have a gap. So enjoy your work. Okay, so Amanda, does that answer your question?
Yeah, I'm glad you told me, so at least I could put it down on my scratch paper. I was just curious if that was okay.
It is totally okay as a check. Okay, starting on a new notepad. How exciting and fancy that is. Let's see. That's not one notepad just for the couple of days we've done. Ladies and gentlemen, I had a notepad left over. Okay, let's do another one. Let's look at 2x to the 1/2 minus 6 equals 0. That'd be nice if you could see it. There we go. Still on 1.6. Okay, we need to isolate this guy with the radical on him. The other problems, we were already there. We didn't have to do anything. We just had to raise stuff to the reciprocal power. But this one, we're going to have to first get rid of the 6 and then get rid of the 2. So move the 6 to the other side. Positive 6. He's a negative 6 on this side. He moves to a positive 6. Keep working. Divide by 2. 1/2 equals 3. And now let's raise this to his reciprocal. That's 2/1, or just 2. 1/2 of 2, half of 2 pizzas is 1 pizza. So that gives us x. Whatever you do on one side, you have to do on both sides. And 3 squared, 3 times 3, is 9. And so that was a little bit easier, but it involved isolating the one with the rational exponent on it first. So clear the 6 out of there, clear the 2 out of there, and then square both sides. Okie doke, let's move to quadratic in form. These take a little bit of getting used to. Remember, that's that one with that little weird mew, a cow with a disability. But I like them. I think they're cool. So these are the ones that are quadratic in form. When I was in class at 8 o'clock, I could not remember what that was technically called at least in the developmental book that I've used. I called it quadratic wannabe, which is a good name for it too. Let's look at our first problem, 17. Radical x plus 52 equals 0. Okay, we've done some baby steps on this one. Let's complete the baby steps. Let's go past the baby steps. When you see that this looks like it wants to be quadratic, that wants to be an x squared, that wants to be a regular x, not a radical x, when you see that, we're going to shift over into quadratic in form, and we're going to write let mu, that really weird variable that you've never used, so it will trigger in you. This is one of those kind of problems. Equals, and it's always going to equal what sits behind the B number. Remember, there's an A that's a 1 here, B is -17, C is 52. So the mu is always going to substitute for what sits there behind the coefficient. So there's where we are. Now what I want to do is rewrite this line, but if I come across a if I come across a square root of x, I need to put in a mu. We're substituting. So this is our substituting step. Substitute in, and in a little bit we will substitute out. Okay, I'm going to start back here because it's easier to start back here. 0 equals 52 plus sign. Oop, radical x, I'm putting a mu in place of that. Then a 17, then a minus sign, and then if you square this, squaring a radical frees him up. This is the square of that. So instead of just mu, I'm going to put mu squared. If you don't really understand fully that last step, that's okay. It's not a big deal. Just put a mu squared and you're good to go. Okay, now we have an actual quadratic equation, a variable squared, a variable to the first power, and a variable to the 0 power. So let's factor it. Mu and mu, the signs need to be the same, and they need to be negative. We're looking for two numbers that multiply to give us 52, that add together to give us 17, and you might not know what that is. So let's start with 1 times 52. That multiplies to give us 52, but it doesn't add together. It adds together to give us 53. Will 2 go in? Yeah, 2 will go in 26 times. That adds together to give us 28. We're getting closer. Will 3 work? No. Will 4 work? Yeah. It goes in 13 times, so we have a winner. Let's put 4 and 13 in there. And now let's do what we do. We've got a 0. We did the factoring. Let's use the property. Mu minus 4 equals 0, and mu minus 13. So we get a positive 13 and a positive 4. Hang on a second. Let's see. Yes, always, Kaylina. If it's a positive, then these signs need to match. They'll either both need to be positive or they'll both need to be negative. So if you have a positive at the back, the signs need to match, and it's always the back one. If you have a minus at the back, then the signs need to be different. So you're always looking at that back guy to determine signs. Brandon, you determine which signs to use. If we had had mu squared plus 17 mu plus 52, if everything here was positive, we'd say, okay, this sign is positive. That tells me my signs need to match. And since everybody here is positive, both signs will have to be plus. But here, we determine first that the signs need to match. But we've got some negative in our problem, so they'll both need to be negative. They match, but they're both negative. And then if there's a sign that's if the minus is at the back, then the signs will be different. Good. And you can ask again. All of y'all can ask again. I get it that some of this, we all have holes in our education, and I get it that signs is one of the biggies. Okay, now we have mu equals 4 and mu equals 13, and you think we're done, but we are not, because this problem is not about mu's. We've substituted in a mu. We have to substitute that back out. This problem is about x's, and we need to end up with x equals. So we're now going to go and substitute back out, and you've got to do it, and that's why we're using this goofy little letter that when you get here, I'm hoping your brain will say, I don't need this. This is weird. I need to substitute back in and talk about x's. So go here. Whenever you see a mu, we're going to substitute back in and say square root of x in place of that mu. So square root of x equals 4. Square root of x equals 13. Now we're back talking to x's, but it isn't x equals, so let's do what we need to do to make that be an x. How do you make a square? You square it. Take a square root and square it. So we get x there. Squaring and unsquaring cancel each other out. Whatever you do to one side, you have to do to both sides. So we end up with a 16 there and a 169 there. And you won't have to check these. They'll work. So we have two answers. We were expecting two answers eventually. And sometimes this doesn't work as magically as the other way. But we have these two answers. They're the only two numbers in the world that will work here. 16 minus 17 is the square root of 16 plus 52 will give you 0. Put 169 in those two places and it'll also work. Okay, that's our first real one to do completely. Let's do another one. Let's look at 6x to the 2/3 minus 29x to the 1/3 minus 5 equals 0. Okay, this is sort of like quadratic. It's like an x squared. That's like an x. That's a constant. So we're going to do quadratic in form here. We're going to substitute in, let mu equal, and if you can stay a half a step ahead of me, you're doing great. If you can't, that's okay. This is just the second problem we've done like this. So we need to substitute in something here to make this look like a quadratic problem. Remember, we're always going to grab what sits behind the b. So we're grabbing that. X to the 1/3 is going to be our mu. So let's substitute in now. I'm going to start back here. 0 equals -5. Oh, there's an x to the 1/3. Let me put in a mu. Now it's starting to look more like quadratic. That's a variable to the first power. Then a 29, then a minus sign. Now this is always, on the ones you get given, will be the square of that. 1/3 squared gives you 2/3. So if we substitute in a mu here, that's going to be a mu squared. And that'll always be a mu squared. You can guarantee it. You don't have to understand it. And then put a 6 in front. Okay. Now we've got a factorable problem. Okay, a little bit less clean because we've got a 6 here. Generally speaking, and almost all the time, 80, 85, 90% of the time, they are not going to use 6 times 1 to get 6 because it's got another pair of factors, 3 times 2. Go for the ones that are closer together. So let's try 3 mu and 2 mu. Here's an example where we've got a minus at the back. So the signs need to be different. When you can barely see that. When you've got a minus at the back, the signs need to be different. I don't know if this is going to be right or not, but we'll give it a shot. We can change it easily if we need to. Now, we're looking for what multiplies to give us 5. We don't have a whole lot of choices there. We've just got 5 times 1. So if I put the 5 here, I'm going to get a minus 15 and a plus 2. That's not going to get anywhere near 29. If I swap it out and put the 1 there and the 5 there, it's even worse. I'm getting a 3 and a 10. So 3 times.
How did you know to get the 3 and the 2 in front of the mu's?
I don't. I just tried that. Okay, there are 2 combinations that make 6. 1 times 6 and 2 times 3. I know it's going to be one of those. Generally speaking, the book will go after the numbers that are closer together. So I'm trying that, but I'm failing. So this is not going to work. So now I'm going to try 6 mu and 1 mu and see if that works. And it better work. I mean, I'm sort of out of choices at this point.
Could 3 and 2 have worked, but you switched the signs?
Switch the numbers or no, because we're never going to get to 29. We're stuck at like 3s and 10s. We need hefty numbers. So we want to get a hefty number here and put that 5 right there and there. Now we've got 30. We've got the bulk of what we need. We need a huge number like 29. And this outside now gives us that 30. So we're in the neighborhood. So no, doing anything with 3s and 2s is never going to get us to the size that we need for the middle number.
Okay.
Not really.
Mm,
No, not really.
Okay is sort of a lie there, Kaylina. I get that. We won't do too many with numbers in front, and so just do the best you can and get help from me, get help from Khan Academy if you want to with trinomials that have numbers in front, but we won't do a whole bunch. Yeah, that's a good rule of thumb. If you've got a big number in the middle, go for big numbers here. Go for a big number. If you've got a middling number like 10 or 11, then 3s and 2s will work. But if you've got a huge number compared to 6 and 5, 29 is huge. And look at it, it's 6 times 5, pretty darn close. So we're going to go for 6 and 1. Now I'm going to mess this up so I can show you how easy it is to correct. The signs need to be different because we've got a minus sign right here. So I'm going to put the plus right there and the minus right there. Okay, we had a 5, we put a 1 there. Now let's look at what happens when we do this. The signs are wrong, but I want to show you how easy it is to correct the signs. The outside now is a plus 30 mu. The inside is a minus 1 mu. That's a positive 29 mu. We wanted a minus 29 mu. So we got the right number. When you've got the right number, that tells you the numbers are in the right place. But what we've got wrong is the sign, so change the sign. So I'm going to change this one to a plus and that one to a minus. Now my outside is a negative 30 mu. The inside is a positive 1 mu, and that's how I'm going to get my minus 29 mu. So the sign, if the sign is wrong, it's a super easy change. Just change the signs. That's all you got to do. If the number is right, if you get a 29 and you wanted a 29, get your hands off those numbers. Okay, let's finish this up. 6 mu plus 1 equals 0, and mu minus 5 equals 0, so mu equals 5. Over here it's a little messier. Move the 1 out. 6 mu equals negative 1 and divide by 6. So we've got mu equals negative 1/6 and mu equals 5. I'm going to bring this 5 down here so they're on the same line. Now let's substitute back out. You know that whenever you see a mu, you got to use x to the 1/3. So I'm going to change this mu to x to the 1/3. Change this mu to x to the 1/3. And now how are we going to get this x to be an x to the first? That's a rational exponent. Going to have to cube that. 1/3 of 3 is 1, so good, we've got an x. Same thing going on here. I'm going to have to raise that to the 3rd power. That's going to give me an x. But whatever you do to one side, you got to do to both sides. 5 times 5 times 5 is 125. Negative times negative times negative is a negative. 1 times 1 times 1 is a 1. And 6 times 6 times 6 is 216. And if you want to use negative 1/6, that's fine, and cube it. That's a legal thing. So parenthesis, negative 1 ABC 6, close the parenthesis. There's negative 1/6. And then raise that to the 3rd power, and you'll get negative 1 over 216. Negative 1 over 216. Okay, let's do one last one. What are we looking at? 6 minutes. That's plenty of time. This one's a little bit simpler. Same concept. This is the last one for 1.6. Let's look at x plus 3 squared plus 4 times x plus 3 plus 3 equals 0. Okay, same game. This is quadratic in form. It looks like it wants to be. There's sort of something squared, something to the second power, plus something to the first power, plus a constant. Let me see, I'm going to move this up and move this up. Here we go. So we need to do some substituting. Let mu equal, and then it's always going to be the piece that is behind the b number. So x plus 3. So let's substitute that in. Start at the back. Oh, there's an x plus 3. Substitute in your little friend mu, then a 4, then a plus, and then this literally is mu squared. X plus 3 is mu squared. That's probably the easiest place to see that happening. Let's factor this. The back end is a plus sign. Back end always tells you about the signs in the answer. Since this is a plus sign, that tells us that our signs down here are going to have to match. They'll either both need to be plus signs or they'll both need to be minus signs. We've only got plus in here, so you're going to put in plus signs there. And now what two numbers multiply to give you 3 that add together to give you 4? That's a pretty easy one. That's about the easiest one we've had so far today. You separate them out. Move the numbers over. And now don't stop there. This mu is this weird little guy, and I'm hoping your brain says, okay, I can't stop there. We need to substitute back out. So what does mu stand for? Mu stands for x plus 3. And solve for x. Move this over, it turns into a negative 3, so we get a negative 6. Turns into a negative 3, so we get a negative 4. So there are two answers here. Negative 6 will work right there and right there. Negative 4 will work right there and right there. Every single time you have a problem that has an equal sign in it, you can substitute your answers back in and check. So you can grade your paper every single time. You can grade your own paper by just plugging them in and seeing if they work. Okay, we are done with 1.6. So what have we done so far? We've done intermediate algebra review, we've done all of 1.5, and we've done all of 1.6. So to be caught up Monday, you need to be through with all of those 3 sections, and we'll start on functions and graphing on Monday. Another thing you need to worry about, so let's see, you got the intermediate algebra review to do, 1.5 to do, and 1.6 to do. You also need to start looking at Proctorio. You can take that test if you would like to. That's not due for another week and 2 days. But those of you who get on stuff, Kaylina, you can always tell what sections are on the test by go down, down, down here until you hit the test 1 deadline. So it'll be chapter, the rest 2.1 through 2.4. You can also look at my math lab and see when the test 1 review is. Everything before test 1 review is part of your test. And you can also look and see what's got a deadline of February 11th, the night before this is due. So all of these have a deadline of February 11th. Then the review test comes, and you can see it here also. So there are lots of places for you to look to see that. So those of you who work ahead and make sure everything's taken care of, take care of your own business, you'll be doing that practice test probably today or tomorrow. You don't have to, though. You've got a week to get it to me, and I'll be reminding you about it. Okay, questions. You can either type it in or you can open your mic. Thank you, Chloe. You too.
Yes, ma'am.
On the question before the one that you're showing right now, so the last question, I kind of got lost. It went a little fast on the subbing out. So I have x to the 1/3 equals -1/6, and then x to the 1/3 equals 5. But I
Good.
got lost in what to do after that.
Okay. There's a fraction here, 1/3. You got to get rid of that rational exponent. So the way to do that is to multiply times his reciprocal. So the reciprocal of 1/3 is 3/1. So we're going to raise it to the third power. Hi, Katie. You okay with that part, Rebecca? That we're
Yes.
going to raise it to the third power?
Yes.
And that'll cancel that, so we get x to the first, so that's cool. Whatever you do to one side, you have to do to both sides. So you're going to have to raise -1/6 to the third power also.
Gotcha. Okay.
And then same thing over here, 5 to the third power. Do you want me to show you how to raise this to the third power on your calculator? Would that be helpful?
Yes, please.
Okay. Anytime you've got a fraction, you'll be using this ABC key that's up here, a third of the way down or so. And so we have this fraction, this -1/6. I'm going to put it in parentheses because I want to raise the negative and the fraction to the third power. So get the parentheses that are there at the belt of your calculator. Open the parentheses, put in -1, and then, because it's a fraction bar, use the ABC key, and then 6, and then close the parenthesis. So there's, open the parenthesis, and then the negative down here. Now, we're not subtracting, which just is a negative. And then 1, ABC 6 will create that. And then raise it to the third power, humpy 3. And that'll give you -1/216.
Okay.
Does that make you happy?
Yeah. I didn't know you could even put it in your calculator like that, so that works.
That's why you bought that calculator. It's a very nice calculator, and I'll show you the wonderful things it'll do as we go. And then 5 to the third, of course, is 125. 5 times 5 times 5.
Okay, and then I did have a question about Proctorio. As far as when we're scanning the room, can we switch back and forth to our front and back camera, or does it all have to be from the same camera view?
It just needs to take in your entire room. As long as I get all 4 walls, we're trying to see that nobody's hiding in the room, that you don't have notes written, or you don't have notes left somewhere, that you don't have a monitor open. So yeah, as long as I can, and I know rooms have 4 walls, so it does not need to be a smooth 360, I would suppose.
But I mean, as far as to show the scratch paper, we can switch to maybe like facing camera and then switch back, and it won't cut us off.
Oh, I see what you're saying. No, I'm afraid that might happen. That actually might happen because Proctorio will latch onto one camera. I don't know. If you want to do it in the practice and let's see, that might be a really good thing for you, since you've got, I had a student last semester who had to pick up his dang PC. He didn't have a laptop, and hold it with one arm. He built up muscles that semester. And hold it with one arm as he showed me his papers, but that's just the way it's going to have to be.
Okay, so I might try that if I can figure it out. And then my second question on Proctorio is, while we're taking the test, let's say we have 7 pieces of scratch paper, but we write really big and we need more scratch paper. What do we do? Do we notify, like on the video, I need more scratch paper, and then show you that scratch paper when we get it, or?
That sounds perfect.
Okay.
Yeah.
Questions about Proctorio too.
Great. Go ahead, Kayleen.
I do my class on a PC, but I have a camera that's attached to the top of my computer, and it's plugged in by USB. The USB cord is kind of long, so when I pick up the camera and move it around the room and then put it back on top of the my screen.
Perfect.
And also, I've got a very abnormal desk, and my computer monitor is facing at an angle. So, and this room is really messy because this is our junk room. So there's lots of cubbies in the desk, and there's lots of crap in the room that I can't physically move because there's a lot of stuff, and it's also my mom's stuff. And in these cubbies holes, there's lots of papers, like real papers, and there's stuff on the walls for when it used to be my mother's room and when she used more of this stuff. I'm just afraid that like I'm not sure I'm supposed to move any of this stuff, but I don't want to accidentally be accused of hiding notes because I don't know what's on all of these pieces of paper everywhere. Because there's lots of open cubby holes everywhere.
Yeah, that's going to be a problem. Is there another place you can take your test that can be more secure?
Not really. I have a laptop, but it constantly has problems with the internet, and I'm afraid it's going to lose connection.
Yeah, that's
And I also don't think it has a camera.
you're not going to be able to take it in a room full of extraneous paper. We're going to have to work on something else. I've had students take their tests in bathrooms. I literally had a student last semester on the roof of his house. Literally, I've got pictures to prove it. So you can go anywhere else, but a room full of paper just isn't going to work. Rebecca, you got something to?
Yeah, I'm stuck kind of in the same situation in the room where I do my schooling in. I do have a lot of stuff down here. Would throwing a sheet over everything and then putting like sitting on top of the sheet work? Because it would be an adventure to throw that sheet up and try to get into anything underneath it.
Yeah, and that would be filmed for sure. I could live with that. I think I could live with that better than having it out in the open. I'm just thinking it will photograph you the whole time. It does not. It's not going to. You will be able to see. The camera will be there on your screen. You'll be able to see what it's seeing. So it does not film your hands. And that's what I'm concerned about. Remember, your job, all of y'all, your job is to prove to me that you're not cheating. And that's where my concern is. The room needs to be clear. Another thing Ms. Campbell talks about is putting sheets over other monitors that are within your reach. So that's sort of the same thing as putting a sheet over a ton of paper. I'm not happy with it. I mean, because you could just have your notebook there. Remember, I'm also making sure that some other student does not have his notebook sitting there. So it's not just you that I'm after, Helena or Rebecca or anybody else who's on here. It's everybody else to make sure they're not cheating and getting an unfair advantage over you. So it really needs to be a clear enough area so that you are proving it. It's supposed to be similar to the testing center, where you have nothing around you except for your scratch paper and your calculator. Rebecca, you have
Yeah, this is going to be a real big problem. I could probably turn on my camera, even though I look like horrible, and like show you what I mean by a cubby. It's got lots of cubby holes because I have the camera and I could turn on the camera. But you might have to.
Yeah, but you're telling me that you've got a laptop, so you can move around a little bit. And I know you've got concerns about connectivity, but maybe you play with that a little.
Because my laptops are constantly dying, so they always have to be plugged in. And I don't have a desk in my bedroom, and that's usually where I keep it. And I don't want to be in the living room because my mom also lives in this house, and
Right.
it's constantly passing through, so it's distractions. And the laptop, I haven't used it very much, and like it has problems with like it gets little pop-ups saying like you have to set up the laptop, even though I've done it 5 times and it just won't go away, and it gets pop-ups really that it shouldn't be, but it does it anyway.
Yeah, that might be a struggle, Kaylina. I don't know if you have somebody else's house you can go to and burrow yourself in a spare room of theirs where they've got better connectivity. But if you're popping in and out, that's going to, I mean, imagine it from the proctorio's point of view. If you are checking out several times during the test, you are checking out and looking up notes. I mean,
Yeah.
That's what it could, that's what we're trying to protect against from everybody doing it. So I'd like for you to think a little bit about the possibilities, just remembering that you want to prove to me that you are using your brain and not your notes, and how we can go about making it work for you. I don't want it to be stressful for you, and I don't want to take off points, and I don't want me to feel like I'm not being fair to everybody else by having you in a room full of paper. So think about it a little bit, and we can talk again. We got time. Charles, you have a question?
Yeah, so what if we have to use our mobile hotspot from our phone for connectivity?
I have no idea what that means in terms of
So
how that's going to
my-
affect your portfolio.
My phone allows me, for instance, if my internet goes down, I can use my phone to be my internet.
Okay.
So if I have to use it during a test, how do I hide my phone so it doesn't think I'm cheating?
Oh, gotcha, because your phone will be in the room.
Yeah.
That's a problem. That is without a doubt a problem. You can't have your phone in the room. You just can't.
Could I hide it?
Because-
Because I have a printer farther from my room. Maybe I think I can hide it from my printer or whatever.
Can it be out of your reach? Would it be out of your
Yeah,
reach?
I can put it out of my reach.
And then I'm making a note here about you. So I want you to show me where it is when you take your test, okay?
Yeah.
If you're using the hotspot, I want to I want you to show it to me on the video when you do your, show me that it's there, and then, you know, cover it up or be far enough away from it so that you would have to get up and go to it.
Okay.
So that would be picked up on the screen. I can handle that. Thanks for asking. Anybody else? I'm
Also,
gonna
so
stop
whenever you
recording.
do the
Go ahead.
room
Like,
scan,
Say it
Like
again,
this is
Charles?
what I'm talking about with like the cubby holes.
Okay.
With like lots of paper cubby holes.
Oh yeah, that's not gonna work. That just is not gonna work, sweetie. I'm sorry, and I know that's inconveniencing to you, and I apologize for that, but there's just no way a room full of paper is gonna be okay. You've got it. It's just not.
Mm-hmm.
Okay, I know there's several other questions. Brandon, I think you asked something about your calculator. Let me grab that right now.
I guess I'll try and do when I do the practice factorial, I'll do it on my laptop in my room,
Great.
and maybe I'll email you when I do that, so you like maybe email me back if that's acceptable.
Sure, I'm a really good emailer. I will do that. That's what this is about, is us communicating to make sure. And I'm sorry about that. I know that's a pain in the ass for you. You don't want to do that. I should have stopped recording long ago. Oh, everybody's heard that word, huh? Everybody's got one, in fact. I know that is, I know I'm creating a problem for you, but it's just to be fair to you and to everybody else. So yeah, let's see what we can do about that and see how that works.
I know I don't have a stable desk in my bedroom, but I've got a little like TV tray, like looking thing, like where it's like a portable flat surface, but it's also not very stable, but it's better than nothing. And
Okay.
the laptop might constantly be moving because it's not big enough to hold the laptop and my scratch paper.
Uh-huh. Play with it a little bit and see. You just want to be in the camera. You can, if you watch,
Do laptops have built-in cameras?
say it again, it's difficult to hear.
Do laptops have built-in cameras?
Do laptops have, okay,
Built-in cameras?
built-in cameras? Is that what you're saying?
Yeah.
Yeah, and I agree with Brandon, Stu. Go to your settings and look for camera.
In the laptop?
I'm just not hearing you clearly enough.
In the laptop, look for the setting for a camera?
Yes, in the laptop. Go down to settings and click on camera or devices. Are you working with a Mac or a PC?
I have a PC, and that's what I'm using right now, but I also have a laptop in my room. I'm not sure what type it is. I think it's a Chromebook, but I can't remember.
Okay. Yeah, we'll play. We'll play with that and see what we can figure out. Or
Okay.
you'll play and I'll give you feedback.
Okay.
Okay, Brandon, wrong kind of calculator. The calculator that you need, if you will go over and look at my, it's a TI 30X2S.
Hang on a second.
Am I still on?
You're still recording, by the way.
So you can see this? I can't see this. How come I can't see this? Let's see. Okay. Okay, there. So it's this one that you need. TI 30X2S. It does not have to be in pretty pink. It can be in any color. $8.46 at Walmart, I think. But that's the one we're going to use. That's the one you need. I hope you can take your other one back. Yeah, that's really similar. Can you take it back, Brandon, and get the 2X? Good, Kaylina. Well, you want the humpy key for sure. That's a handy key. So yeah, take that one back and get this one. And then Amanda.
I
Good.
know I'd already asked you about my cats. I forgot to ask you about my artwork on my wall.
Artwork on your wall is fine.
Okay, because it's covered in like freestyle artworks that I have signed by famous people. And I didn't know if that would be okay since it has words on it, but I mean, it's not math.
Yeah, that's fine. Show me on your room scan because that's part of your room scan anyway. And as long as it's not math, it's fine.
Okay, I just wanted to make sure since there were pieces of
Good-
paper
good
and I
idea.
didn't want it.
Yeah, good idea.
I have one last concern. I just thought of before I was gonna leave. I've also got 4 dogs, and they love to bark. So
That's fine.
Okay.
As long as they don't bark out the quadratic equation, we're good.
Okay. I'm gonna go then.
Okay, I'm going to stop recording.